Right. Hopefully, you just watched a demonstration for rate determining steps that involves pouring solid or liquid, it doesn't matter, through different sized funnels to show the effect of the one slow step in a chain of steps. And that no matter where that step occurs in the chain of steps, it will determine how quickly the beaker is filled. I have a picture of it here, and the video was linked before this on the page or in the playlist. And so, what this rate determining step is just basically the slowest step. So, the slowest step in any mechanism is our rate determining step. And the rate law of the rate determining step is going to determine the rate law for the overall reaction. So, that overall reaction isn't a sum or product of these different rate laws. Instead, it really just depends on the rate law of whichever step is the slowest. That could be the first step, the second, the third, doesn't matter. It's going to determine what happens at the end of the day for the overall reaction. And so that means that if we can look at a proposed mechanism of elementary steps and figure out which one's a slow step, and then we'll have an idea of at least the order of that rate law that we should expect for the overall reaction. Which is a really helpful tool as we start to tease apart the data we get out of kinetics experiments. So, looking at our previous example that we first introduced of NO2 and F2 combining to eventually form two NO2F molecules. So, here's my reactants and products. We looked at this as a two-step mechanism that had a first step that was going to have a really high activation energy, and a second step with a very small activation energy relatively. And so, because this activation's energy is large, we will have a slow step here. So, a large activation energy is telling us that this is our slow step compared to the second one. And so, our first step right here will be our rate determining step. Now, we're going to use this as we learn about validating mechanisms. So I'll just kind of preview this here. So we've already talked about how the elementary steps need to sum up to the overall reaction. And now we'll also see that our rate law that's predicted by our mechanism should be consistent with the experimentally observed rate law. That means the rate law that the slow step of our mechanism predicts should match the orders that we see experimentally for the rate law for the overall reaction. And so we'll walk through this process of validating in the next video.